How do you make lightning out of dust? Lightning is supposed to need a storm, rain, ice, thunderclouds. This has none of them, and it's flashing hundreds of times. Picture a volcano tearing open the night. Fire, smoke, a towering column of ash punching miles into the sky. And then, lightning. Not one bolt, but hundreds, ripping through the cloud like cracks spreading across black glass. But here's the strange part. There's no rain, no storm, no thunderclouds anywhere in sight. So where is all of this lightning coming from? The lightning we know is born inside storm clouds. Tall towers of rain and ice, crackling with trapped energy. But a volcano has none of that. It's just scorching hot rock, blasted into the air as dust. And yet again and again, the biggest eruptions light up from the inside with lightning. It happens so often that scientists gave it a nickname, a dirty thunderstorm. A thunderstorm made not of water, but of shattered rock, which only makes the mystery stranger. How do you make lightning out of dust? To find the answer, we have to zoom in, way in, on the ash itself. Volcanic ash isn't soft, fluffy powder. Up close, it's a swarm of tiny, jagged shards, pieces of pulverized rock and natural glass, many of them smaller than a grain of flour. When a volcano explodes, these particles are fired upward at brutal speed, crammed together so tightly they're constantly smashing and scraping past one another. And that endless rubbing, believe it or not, is where lightning begins. You've actually felt this trick yourself. Rub a balloon on your hair and the strands leap up to follow it. That's static electricity, tiny electric charges jumping between two surfaces that rub together. Now take that simple idea and scale it up to nightmare size. Billions of rock fragments, grinding past each other inside a roaring tower of ash. Every collision shaves off a little charge. And down near the vent, the magma is being torn apart so violently that it sheds charge too. Bit by bit, the whole plume starts to hum with electricity. But scattered static still isn't lightning. For that, you need the charges to split apart. As the ash rockets upward, the cloud begins sorting itself out. Lighter, positively charged bits drift toward the top, while heavier, negative ones sink toward the bottom. Layer by layer, the plume divides into separate zones of opposite charge, like a colossal battery, quietly building itself in the sky. And every battery is waiting for the same thing, a way to let go. When the gap between those charged zones grows strong enough, the air itself surrenders. It can no longer hold the two sides apart, so the charge rips straight through it in a single blinding flash. That's your lightning, and it doesn't stop near the ground. Higher up, where the plume slams into freezing air, water freezes into ice, and those icy specks collide as well. A second hidden engine, throwing bolts near the very edge of space. So how big can this get? In January 2022, an underwater volcano near the islands of Tonga erupted with the force of hundreds of atomic bombs. What came next wasn't just an eruption. It was the most intense lightning storm ever recorded on Earth. Over roughly 11 hours, the plume unleashed nearly 200,000 flashes. At its peak, that was more than 2,600 bolts every single minute. Some of those bolts struck higher than any lightning ever measured, up to 30 kilometers above the sea, brushing the edge of space. And the flashes arranged themselves into enormous glowing rings, one of them nearly 300 kilometers wide. A halo of electricity broader than entire countries. But the most haunting part isn't what the lightning looks like. It's what it leaves behind. A single bolt can reach around 30,000 degrees, roughly 5 times hotter than the surface of the sun. When it tears through the ash, it melts those tiny rock shards in a heartbeat. As they fall, they cool and freeze into perfect microscopic spheres of glass, far smaller than a grain of sand. So after some eruptions, the lightning quite literally rains down, as a fine dust of tiny glass beads scattered across the ground. And here's the twist that changes everything. Those flashes turned out to be incredibly useful. Most volcanoes erupt far from any cameras, often buried inside their own ash, impossible to see. But lightning can be detected from hundreds of miles away, instantly, at the speed of light. So scientists now read it like a heartbeat on a monitor, tracking an eruption as it unfolds. In the dark, through the ash, even from the other side of an ocean. The same violence that looks like pure destruction has quietly become an early warning system. It's tempting to see an eruption as nothing but raw, mindless force. But look closer, and there's something almost intentional hiding inside the chaos. A volcano doesn't simply hurl rock into the sky. It builds its own storm. It sparks its own lightning. And as it rages, it signs its name in tiny, perfect beads of glass.